Hello everybody and welcome to another Advent of Code video. A long time no see, as I was quite busy with all the errands after returning from Canada, and I'm quite a bit behind schedule now. It's already day 15 out, so yeah, I need to still solve 4 more problems. So let's take it one step at a time and let's do problem number 12, or 2 problems for day 12. So today it's gonna be hill climbing algorithm, and the elves are trying to navigate me through the river using a height map of the surrounding area. The height map is written using letters, where each letter represents elevation. A is the lowest, Z is the highest. And there is also a starting position and some the destination position, E. So our goal is to get to the final E destination. And also to make as few steps as possible, so it seems like a shortest path search algorithm. And our rule for movement is that we can climb only to a square which is at most 1 level higher than the one that we are currently on. So yeah, that means that basically this would be kind of a breadth first search algorithm where the edges exist if the neighboring cell has an elevation lower or one higher or lower than the one that we are currently on. So that makes sense. So our goal is to find the number of steps we need to take to get to the final position. So let's try to build this thing, and I will copy the sample input. I already prepared the day, the projects for this day, and I will just copy the input file and put in the the value here. So this is the input, and let's build it. So I will start by reading let's see. I will read the lines and then I will transform it into some more nicer format. So I will create a map, which will be an equal. Yeah, this makes sense. So no, not like this, but it will be a car of. All right. Writing on this keyboard again after a long time, so it's gonna be fun to watch probably. So the width is equal to, well, let's create a variable for it. So width is gonna be equal to, yes, exactly, and height will be this. Okay, oh, right, width and height. And there we have. Now we will read the input to the map, and yeah, it was actually a very good suggestion from Copilot there. So I will try to trigger it again like this. But what we are gonna do is also store the position of the start and end. So start position is, well, point, or let's do default, and use write like this, and the same will be for the end position. And point is a structure that I have defined in my tools project, so I will just reference it. It's X and Y structure, nothing too fancy. Just need to import it from tools. All right, and now we'll have to initialize it. So if let's use the newly assigned value here. So if map right equals caps lock. How did I? Okay. Yes. Seems that Copilot has already seen attempts to solve this problem already, so it's suggesting quite useful things. So specifically S and E, and it is exactly what we need here, so I will use that. And now let's implement the breadth first search algorithm. So for breadth search, we need a queue, exactly. So we need a queue that will we will use to kind of store the next cells that we want to visit, and we need to enqueue the start position first. So we'll enqueue it, and now while the queue is and well, technically the problem should have a solution. So technically we shouldn't need to use this condition. We could use the condition of, well, we could just break when we're done. So, but let's do it like this, so that we don't get into an accidental Stack Overflow exception. So what we'll do is the queue, the current, yes, that's right, the current cell, and now we will go through all the possible directions that we can go. So for each, oh yeah, that's true. We need to also know how many steps we had to take to get there. So what we will also create is steps array, which will be just int array, where we will store the number of steps for individual cells. So for each, well, next steps will be equal to steps at x, well, current x, current y, and after we take this we will, and +1, yes. It's very good that Copilot is helping me, because otherwise I wouldn't know where the keys on this keyboard are. I'll have to take some specific days to learn it more. But Moonlander, just to see my current configuration. So I'm not really sure where I have the plus sign. It should be somewhere. Well, I will find it later. Anyways, so for each direction, I have this helpful method, array of directions without diagonals, because you can move only horizontally. And for each direction, we will try to go there to see if we are not at the border or outside of the bounds of the map. And if not, we will visit that location. So and we will go there only if it wasn't, if the location wasn't visited already. So let's see. Initially, all the steps, all the points in steps are equal to 0. So we can use 0 as the marker, kind of. but in the case of the start position, we need to make sure that we don't visit it again, and it's gonna have 0 on it at the beginning. So how do I approach this? So, well, yeah, okay, let's do it like this. New position is gonna be current plus direction, yes. And for the new position, we'll first check if it's in bounds. If it's greater than 0. Oh, greater than equal to 0. And if maybe Copilot could help here a little bit. No, it's greater than equal to 0, and new position x is less than width. New position. Okay. How do I? Okay. New position. Y is less than height. So we need to check if we're in bounds, and if the new position is not equal to start position. And if all these pass, then we can continue. So if oh, and also yes, of course, and new steps at a new position x y is equal to 0. Yes, that's what we need. Oh, right. Equal to 0 and tab. All right. So this is the correct condition. So if we already visited that location, we don't need to visit again. No reason to do that, because we had to visit it in a more recent position, in a more even from a lower number of steps. Okay, so now if map exactly, so if the position is E, like end, we found the end, and because we are using a queue, we had to find it. The number of steps that we had to took is the lowest possible. So this is enough. We can end the program and output the result. And if it's not an E, then we will. Right. We don't have to check actually for start position, because we do actually, because capital letters are before a lowercase letter. So yeah. So if the new if map x less than or equal to so basically we'll check if we can go there if the position is reasonable. Now I have to find the plus sign on the keyboard. Okay, that's gonna be a great experience. Where could it be? So on. Okay, so bear with me. This will be a struggle. So what is where do we have? Nope. 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 Right. what is that plus sign? Oh gosh. Right, I did not yet have to write that on this keyboard, so this is a very interesting issue. Oh, right, of course, it's on the same key as equal sign, but with shift. Right, so now you know where the plus sign is. That's great. And so if the new position is at most one higher than the map, the position that we are currently on, we will write the next steps there, and we'll enqueue the new position. Very reasonable, and I think that should be enough to resolve this. And we don't have to actually store the end position at all, because we will just find it by going everywhere with breadth first search. So let's try to run this against the simple sample input, and it should output nothing. Interesting. So where did we go wrong here? Yeah, so we should somehow be able to go. Okay, it doesn't even reach this point, so what is the problem? Yes, we should go there with current plus position. Yes, that makes all sense. So why don't we? Yes, that's okay. So this condition never succeeds. Why is that the case? Of course, we have to ignore the S. Yes. So from starting position, you can go anywhere. So that's of course quite important thing here. Or basically, what we could. Oh. What we could do is that we, at the beginning, adjust the inputs a little bit so that we can go anywhere from the start position. So instead of it being capital S, we will mark it as map start position X start position Y, and we'll mark it as oh. Now we have to find this one, yes, and we'll mark it as a Z because that's the last letter, and from there we can go downhill to any other location. So this should be enough. Yes, now we're unqueuing, and if we're lucky, oh, it's 25. 25 is not completely right. I think it should be 31. So where did we make the mistake? Okay, let's put a breakpoint here to see where we get here from. So the current position is 5, 3. Right, 5, 3. So from here we go to. Why can? Oh, we cannot go directly there. Right. Maybe I didn't understand the rules. So, right. The final location has elevation of Z. Great. I missed that completely. So we need to account for this specific problem. So as let's do it like this. So we will store the end position. We will use this to store it. Then we will mark it at Z because it has elevation of Z, as we learned now. And finally, we will we will adjust this code. So if new position equals to end position, then we will output the result. And I think this should solve it. Or it didn't. Okay. Well, oh, of course, because we, even if it is the end position, we need to actually satisfy that condition. So I have to move this here and do it like this. Now that I'm pretty confident is correct. Right. And let's run it. And now it's 31, so let's run the code against the full input, which is significantly bigger. 472. Right. So let's see, I will plug it here. And that's correct. Okay, so that's the first part of the problem. Now let's go for the second one. So now we will start on. We can start on any square that has elevation A. So essentially, we're trying to find a path from all the A's and then pick the one that's shortest. So this should be quite a small adjustment. First off, I will reference my tools. And now what we will have to do is run this multiple times. So yes, so S counts as being elevation A. So A and position is Z. Okay, and what we are going to do is that we will move the steps out of here inside of here. We will also move this here. So if we find the starting position, we will mark it as being an A. Right. Equals A. And all right. Oh, what's happening? Save it, and now we will run this method multiple times. So we will try to find the minimum of all the runs. So for X we're not getting any more suggestions from Copilot for some reason, which is okay, I guess, but it would be nice because this would be quite easy for it to suggest, because they were just going through a two-dimensional array. So like that, and we for each of those points, if it's A, if it's an A, we will find path. So well, let's have a variable. It will be initialized into max value, and we will try to improve it in each run. So we'll do this math min solve y. Okay, so this will be the runner, and the solve method, let's create it, is gonna be here, solve, which will take in X and Y, and we will initialize that as a start position. So So start position is going to be X and Y, and we will no longer adjust anything about the array here, so this must be moved here. Here, okay. So is that enough? I think it could be. What is this complaining about? It can convert. Yes, right. We need to return that best number of steps. And if we reach the end without finding any result, we will just return and max value as a fallback. Right, we don't have to output every single one. That would be a waste. but we need to output the actual best results. Let's see. 465 is less. It is less, so it could be the solution. 465, right. All right, good. So that was the right solution. Okay, so we've solved day 12 of Advent of Code. And now there are 3 more days ahead of me to catch up even. But I'm not sure if I will be able to catch up quite as fast as possible. So I will just probably like shift the schedule a little bit. But so far so good. At least from the problems that have been that we tried so far, we have all the stars, so that's a good thing. So I will of course push the changes from this day to my GitHub. Let me do it right now. I will push it there so you can reference it or see and run the solution locally. And in the meantime, keep coding, have a great day, and if you subscribe, you can get notified about upcoming Advent of Code videos. So see you in the next videos, and bye bye.